Okay, so today we're going to do some differential equations. And so the first one's regarding Euler's method. And so we're solving for y at when x is 1.5, and we know that y of 0 is 3, and that our x intervals, our change in x, is going to be 0.5. So the way we do Euler's method is we're going to set our equation up. So y of 0.5 equals 3, which is y of 0, plus we can solve for dy dx when y is 0, and that's going to be negative 8. And then our 0.5, which is our interval, and that is going to equate to negative 1. So then y of 1 is going to be negative 1 plus, we plug in 0.5 and negative 1 there, and we actually get negative 0.5 plus 0.5. Actually, yeah, this is just 0. And then times 0.5, and this will just get you to negative 1 once again. And then finally, y of 1.5 is going to be negative 1 plus, I believe this computes to 1 times 0.5, which will get you to negative 0.5, and your final answer is 1.5 comma 0, negative 0.5. All right, let's do another one using Euler's method. We have our dy dx. We know that y is 0 is 1, and using 5 steps, we want to find y equals 1. So if it's 5 steps, we just divide 1 by 5. Our change in x will be 0.2. And so from there, we can solve y of 0.2 equals 1 plus, we can plug this stuff in, and we get 0 times 0.2. So this is just 1. Y of 0.4 is going to be 1 plus, this is about 0.04. If you plug that in, you plug in your 0.2 as x, and then 1 is y. Sorry, it's exactly 0.04. That's my bad. Multiply that by 0.2, and this will be 1.008. Then from here, we're going to do, it's going to be more approximations. Y of 0.6 is 1.008 plus, plug everything in, and you get about 0.164 multiplied by 0.2, and that's going to be about 1.041. We go to y of 0.8, that will be 1.041. Plug in your previous, your x is 0.6, y is 1.041, and this will be 0.399 times 0.2 as usual, and that will be 1.121. And then finally, y of 1 equals 1.121 plus, plug everything in, and you get 0.809 times 0.2, and your final answer is 1.283. All right, so now we're just going to do some separable equations as our last practice. And so for this, you want to keep all x terms on one side, all y terms on the other side. And so we know that we can rewrite this as, hold up, sorry, 1 second. We can rewrite this as, we move the y and l and y, so 1 over y, natural log of y, dy, equals, this is going to equal 6x e to the x dx. We can take the integral of both sides. And here, for this integral, we can set u equal to ln of y, du equals 1 over y, dy. And so from there, this integral is going to be the integral of 1 over u du. And that's going to get you to the natural log of the natural log of y, plus c, of course, but we're just going to keep that on the right side. And then on this side, we can do integral by parts, and this will just get you to, I believe, 6x e to the x minus e to the x. Sorry, 6e to the x minus 6e to the x. And so from there, I'll just drop this down. We're going to get 6x e to the x minus 6e to the x. And from there, we're going to add our plus c here. And let's erase this now. So from here, now we just have to solve for y and then eventually solve for c as we're given our initial y of 0 equals 2. So solving for y, we get natural log of y equals e to the 6x e to the x minus 6 e to the x plus c. And then further, we get y equals e to the 6x e to the x minus 6 e to the x plus c. And here we can just solve with our y of 0 term. We plug in 0, we get 2 equals e to the 6 times 0 is going to be 0. So this term is going to be 0 minus 6. E to the 0 is 1 plus c. So then if 2 equals e to the c minus 6, we know that ln 2 equals e to the c minus 6, and therefore the natural log of 2 equals c minus 6. C equals ln 2 plus 6. And then our final answer will be, I'm actually just going to write it right here. I'm going to erase this. Final answer will be y equals e to the 6x e to the x minus 6 e to the x plus the natural log of 2 plus 6.